Lab TV travels to an Air Force research lab in Dayton, Ohio, to meet engineers who design and build antennas.
Antennas are the eyes and ears of everything we do. Communications, TV signals, radio, cell phones, they all connect to a system with an antenna.
Antennas send and receive energy using radio waves. These waves can be longer than a football field or shorter than a penny. Radio waves are the longest waves in the electromagnetic spectrum.
The electromagnetic waves propagate through the air, and that's the basic beauty of the antenna. They'll create a wave that will travel through the air, and it will impinge on another antenna in another system, and then it will be processed to create an image, voice.
Pictures and sounds can be encoded as a guided wave, carried to an antenna, and sent through the air as a free space wave. That wave is then received by another antenna many miles away, so the information can be decoded for your television.
You have antennas for radios, like these big antennas that are mounted on a tower. Those are big antennas for big waves. The smaller the wave, the smaller the antenna. They are directly proportional. For systems like a cell phone, you need to have a very small antenna.
And every system, whether it's a cell phone network or a radio station, operates on its own specific wavelength. So it needs an antenna designed to receive that wave.
Normally, specific antennas will be as long as half of that wavelength. And that's how they operate. They are able to resonate at that specific frequency.
Frequency is measured in units called Hertz.
Frequency is how many wave tips pass through a point in 1 second.
And wavelength is measured from peak to peak. Radio wavelengths range from 100 kilometers to 1 millimeter.
There's a real simple relationship between frequency and wavelength. They're inversely proportional. So as the frequency gets higher, the wavelength gets shorter. The relationship is that the frequency times the wavelength is equal to the speed of light. It's 186,000 miles a second. It's 300 million meters a second. To a transmitter and a receiver here on Earth, that's virtually no time at all to go from one point to the other.
If you're listening to a radio station, 98.1 FM, that means it's broadcasting at a frequency of 98.1 megahertz, or 98,100,000 hertz. Using the formula, you can divide the speed of light by that frequency and get the station's wavelength of 3.05 meters. The engineers design, build, and test antennas in lots of shapes and sizes, to go on airplanes, inside radios, or even on huge towers. They want to create the best antenna for each job.
So this is a fairly standard horn antenna. If I want to change the direction of the beam of that antenna, I pretty much have to physically point that antenna. Now this is a phased array type of antenna here. Each one of these little holes is an individual antenna element, and that allows me to electronically steer the beam so I can move the beam around in space without ever having to move the antenna itself.
Some of the antennas are a lot smaller. This one will be the size of a quarter.
We were trying to create the smallest antenna possible, but we wanted to have the best performance possible. That's the challenge.
And solving those challenges is what being an engineer is all about.
The good thing about engineers is that we grab what the mathematicians do and the scientists do and the equations and all the research, and we put it into a practical application. That's what engineering is putting math and science into something that we will be able to use in our life.
To find out more about engineers, antennas, and radio waves, check out labtvonline.org.